Good evening. Today's lesson is going to be we're going to be continuing with polynomials, and we'll be looking specifically at adding, subtracting, multiplying, and dividing. So let's get started. All right, so key points to pay attention to in lesson 10. Monomials, binomials, or trinomials can be added or subtracted. And as we discussed in last lesson, a monomial is simply that has a single term. So mono means one and nomial means term. So a monomial is a single term. A binomial, bi means two. So binomial is a two-term polynomial. And then a trinomial is a polynomial that has three terms. And then poly means many. So a polynomial is a mathematical expression with many terms. So in some cases, a polynomial needs to be specified before it can be added or subtracted. So when you're subtracting polynomials, you want to distribute the second polynomial, changing the signs for coefficients, and then combine all the like terms. We will see examples of that coming up. When you're adding polynomials, one variable, just keep in mind that on the math reasoning test, you may be required to do such to add polynomials with one variable. And you can only add polynomials when they have like terms, including variables and exponents. So when you see polynomials with parentheses linked by an addition sign, then you want to add by combining the like terms across the polynomials. So here's an example, and let me zoom in. So I went in with a marker to so that you can keep track of what's going on with the terms. So this is an example of a polynomial where we're adding two trinomials together. 3x squared plus x plus 4 is being added to 2x squared plus 2x minus 16. Color-coded all the like terms. So we can see here that we have 3x squared and 2x squared. Then we have, so those are our terms with a squared variable. The variable is x in this particular instance. And we have x plus 2x. Those are our single exponent variable. So when I say single exponent, in the last lecture, we discussed that when you see a variable that doesn't have an exponent written next to it, we automatically assume that that variable is being raised to the power of 1. So we have two variables in this case that are being raised to the power of 1, and that's x and 2x. And then we have two coefficients. As discussed in the last class as well, a coefficient is just a number that's written within the context of a polynomial, but it doesn't have a variable next to it. And we have two such coefficients. We have 4 and we have negative 16. So to add these polynomials, you simply want to, let me zoom out. I think it might be easier to read the slide in its entirety. So to add these polynomials, you simply want to combine the terms that are similar. So we start with the greatest power, which happens to be 3x squared plus 2x squared. And when I say greatest power, we also discussed in the last class that the polynomial with the greatest power is the one polynomial term. The greatest power is the one that has the variable raised to the largest exponent. And in this particular instance, the largest exponent, when we're comparing all our variable terms, the term with the largest exponent is, I should say the terms with the largest exponents are 3x squared and 2x squared. So we're going to add 3x squared plus 2x squared. That gives us 5x squared. When you see like terms, you're able to combine like terms like a regular addition or subtraction, or we'll see down the line. And you're able to do that because they both share the same variable raised to the same power. So they're like terms. And so we just proceed with addition as normal. 3x squared plus 2x squared is 5x squared. And then we go to our next set of like terms, and that's x and 2x. So we add those together, x plus 2x is 3x. And then we go to our coefficients. 4 plus a negative 16 is negative 12. Then we combine the results. And so we have the answer to our initial polynomial expression is 5x squared plus 3x minus 12. So sometimes an expression needs to be simplified before you can add or combine like terms. So again, if you pay attention to the color coding, we see that our like terms are 5x squared plus 2x squared. And then with our single exponent variable, we have 8x and negative 6x, and also 14x. And then we have 4 as the only coefficient. So what we're going to do to simplify this particular expression is we're going to start with the second parentheses, and we're going to simplify everything in the second parentheses. We have negative 6x plus 14x. That gives us 8x, right? Then we're going to combine like terms across the entire polynomial. So we have 5x squared on this side, on the left-hand side of our addition sign here, we have 5x squared. And on the right-hand side, we have 2x squared, right? So 5x squared plus 2x squared is 7x squared. And then you're going to use the simplified expression from the first step to add your second set of like terms. And in this case, that would be 8x, which we have from our original expression, and then another 8x, which we got from subtracting 6x from 14x, okay? 8x plus 8x is 16x. And then you simply just combine your results into one polynomial. We have 7x squared, which we got from adding 5x squared and 2x squared. We have 16x, which we got from combining 8x and 8x. The first 8x came from the original expression or the original polynomial. And then the second 8x we got from combining the two like terms on the right-hand side of our addition sign. Follow the color coding, I think that makes it a lot easier. And then we got negative 4 from the original expression as well. And there's nothing to add or subtract. There's nothing to add to negative 4 or subtract from negative 4 because it's the only coefficient, right? It's the only term that's like it in our entire expression. And so this is our simplified polynomial expression of this larger expression that we were given in the original question. When you subtract, you're simply reversing the signs within the second polynomial. So you want to be careful to make all negative signs positive. You'll see examples of that coming up. So pay attention to this to make sure that you avoid errors, okay? So in this particular example, we're being asked to subtract 3x squared plus x plus 4 from 7x squared plus 2x minus 16. So you want to start by distributing the negative sign, and that's why I have these sort of color-coded markings here so that you can see what's going on, right? And so we just simply distribute the negative sign. Again, in the last lecture, we discussed that you can treat this negative sign as a -1. And so when you distribute -1 across this polynomial, this trinomial expression, this three-term expression, you'll be left with a positive sign outside the brackets and the negative sign applied to every single term inside the brackets. So let's start. -1 times 7x squared will give us -7x squared, as you can see here. Then -1 times 2x will give us -2x. -1 times a -16 is a +16. Remember from our lesson on signs that when you multiply two negative signs with each other, the resulting or the outcome is positive. So that's where this -16 is coming from. So now that we've distributed our negative sign, we're going to drop the parentheses from the entire expression and then combine like terms, okay? So that's what's going on here in this step. We'll just start with the very first set of like terms, which is 3x squared and negative 7x squared. So you always want to treat each term or refer to each term according to whatever sign is next to it. When we don't see a sign next to a term, we assume automatically that that term is positive. So we have a positive 3x, we have a positive x, we have a positive 4, we have a negative 7x, we have a negative 2, and we have a positive 16. So we just start, or we proceed rather, by combining like terms. 3x squared minus 7x squared is negative 4x squared. When you, again, I think it was in the last lecture we discussed that when you don't see a number next to a variable, you automatically assume that that coefficient is 1, right? So we have an imaginary 1 here that's not written. So when you add 1 to negative 2, you have negative 1, and that's where this negative x is coming from. Then our next set of like terms are our two coefficients, 4 and 16. We add those together. 4 plus 16 is 20. And so this is the simplified form of our original expression. We cannot simplify this any further. And so this is our final answer. And the reason we can't simplify this any further is because our final expression contains unlike terms. We have a negative 4x squared, we have negative x, and we have 20, okay? So because these three terms, these three individual terms are dissimilar, or they're different, or they're unlike, cannot do anything further with this polynomial. And so we have our final answer in terms of the outcome of subtracting this original expression. Note that when you're subtracting a negative constant or coefficient, it's essentially the same as adding a positive. Let me just go back to the... So remember, we distributed the negative sign across everything inside the expressions or the terms to the right of the negative sign. And once we did that, we replaced the negative sign with a positive sign. Okay, and so that's what this note is telling you here, that when you're subtracting a negative constant or coefficient, it's the same thing as adding a positive. But you want to make sure that you're distributing the negative sign to everything to the right of negative sign. In the next example, watch what happens to the negative coefficient inside the second set of parentheses when the sign is distributed, okay? So in this example, we're being told to subtract x squared plus 2x plus 3 from 4x squared minus x plus 6, okay? So immediately, what you want to do, as we did in the previous example, is start by distributing the negative sign across the terms to the right of your subtraction. And the reason why you want to do that is because it makes sense. Imagine that everything in here is a large 5, okay? That imagine that we've added all these because a variable essentially is an unknown number, right? So because we don't know what that variable is, or we don't know what that number is, we represent it with an x, because essentially we've decided, or mathematicians have decided, that today x could be 5, tomorrow it could be 7, and then next week it could be 9. And since we don't know what number this is truly, we're going to represent it with x. So anytime you see the same variable within an expression, know that they represent the same number. So if x is 9, then what we're doing here is that we're squaring 9, and then we're multiplying 2 by 9, and then we're adding that result to 3, right? So 9 squared is 81. 2 times 9 is 18, so 81 plus 18, that's 99. And then 99 plus 3 is 102. Okay, so imagine that instead of these three terms, we have a large 102 written here, okay? This example or this question is telling us to subtract 102 from everything that's to the right of it, right? And so that's the reason why we distribute the negative sign, because everything here, these three terms have to be subtracted from 102. And so we make sure that every term to the right of the negative is subtracted from whatever we found on this side by simply distributing the negative sign, and that ensures that we don't forget to subtract absolutely everything on the right-hand side of the negative sign. So, and again, as we discussed earlier, we imagine that there was a 1 here. So negative 1 times 4x squared gives us a negative 4x squared. Okay, and that's what you see here. Or let's start with the first line right here. And then negative 1 times negative x gives us a positive x. Remember, as discussed earlier, two negatives multiplied together, the outcome will be positive. And then negative 1 times 6 gives us negative 6. So once we've distributed our negative signs, we're going to drop the parentheses and combine like terms, right? And so we look at our entire expression. This is after we've we've distributed the negative sign and dropped the parentheses. And this is the expression that we now have: x squared plus 2x plus 3x minus 4x squared plus x minus 6. And so now you group the like terms, right? We have x squared and we have negative 4x squared. And so that's grouped over here in blue. Next, we have 2x. And then what else is similar? We have x, right? And that's grouped over here in purple. And then finally, we have our coefficients left over, 3 and a negative 6, and that's what we see here in light blue. And then we just simply proceed with the operation as needed. So in this particular instance, we start with our terms with the greatest power. X squared minus 4x leaves us with negative 3x squared. 2x plus x leaves us with 3x. And 3 minus 6 is negative 3. And so this is as far as we can go with this polynomial, because now we have three unlike terms that we can't combine. And so we leave this as our final answer, or we can state that this is the outcome of subtracting this polynomial expression that we were given originally, okay? So more practice questions, make sure that you're working on those. I've also posted the quiz assignment, the new quiz assignment. I know that you're still working on the second one, but you know, just in case you happen to be done early, you can start working on the new quiz assignment. If you're still working on the second one, that's okay. Just know that the new quiz assignment is up as well.
Thank you.
Okay. Some polynomials contain terms with different variables. So for example, the binomial 2x plus 3y, and again, this is a binomial because it has two terms. 2x is the first term, and 3y is the second term. So when you hear term, or if your test mentions term, just know that it involves a coefficient or a number next to a variable, or just a coefficient written on its own within the context or the framing of a set of expressions, or an expression, polynomial, or binomial, or trinomial. So in this case, we have a binomial 2x plus 3y, and it contains an x term, 2x, and a y term, 2y. So you add, subtract, and simplify polynomials with more than one variable, just as you do polynomials with a single variable. However, you have to be careful to add and subtract only like terms. So in this particular instance, we cannot add 2x plus 3y because they are unlike terms, okay? Remember that in all polynomials, like terms have the same variable and the same exponent, right? And so in this particular instance, 2x, the variable is different, but they have similar exponents, right? X is raised to the power of 1 and y is raised to the power of 1, but we still can't add them together because the variables are different. So the only time that you can add terms together or two or more terms together is when the terms in question have the same variable and the same exponent, okay? So if this was 2x plus 3x squared, you still couldn't add it. Why? Because the exponents are different, okay? So just keep that in mind. That's what this note is letting you know. So when you're simplifying polynomials with more than one variable, you want to make sure, again, as I mentioned earlier, that you don't combine unlike terms. And unlike terms essentially are terms with dissimilar variables and powers, or variables and powers that are different. So for example, in the polynomial x squared plus 2x plus y squared plus 3x plus 2y, the only like terms are the two x to the power of 1 terms, right? And that's 2x and 3x, okay? You can combine 2x and 3x, but you cannot combine x squared with any other term, nor can you combine the y squared or the 2y with any other term. So the simplest version of this particular polynomial would be x squared plus 5x plus y squared plus 2y, okay? And we got that simply x squared, we leave that as is. 2x plus 3x is 5x, okay? And then y squared, we got that from our original expression, we leave that as is. And then 2y also coming from our original expression, okay? And notice that not only are in our final expression, the terms are grouped according to their variable and written from greatest power to least, right? So we have our x squared terms grouped first. We have, and then from greatest power is we have x squared plus 5x. And then we go to our next set of terms. We group the y's together. We have y squared, the greatest power, plus 2y, okay? This would be the simplest version of this initial polynomial. You can't add or do anything further with this final version, okay? A term that consists of two or more variables multiplied together cannot be combined with terms that contain only one of those variables. So for example, you cannot combine 2xy plus 7x. However, you can combine 2xy plus 7xy to get 9xy. Okay, so it's basically just you keeping account of every single variable that you see. It's a matching game, really. So on this side, these two terms don't match, do they? Because we have an xy term and then we have an x term. On this side, we have two xy terms. They match, so we can add. Okay, you can think of it that way if it helps. So in this example, we're being asked to simplify 6x times y raised to the power of 4 minus 20x squared minus 3 plus x times y raised to the 4th power plus 12x squared minus 30. So again, you want to start by grouping your like terms, and then you want to add and subtract as appropriate. So I've gone in with a marker, a digital marker, and grouped our like terms. We have 6x y raised to the power of 4, and we have a positive x y raised to the power of 4, right? So when we add those two together, we have 7xy raised to the power of 4. Then we go back to our expression to find our next set of like terms, okay? We have a negative 20x squared and we have a 12x squared. So negative 20 plus 12 is negative 8. And so this is where we get this negative 8x squared from. Then we have negative 3 plus negative 30, or negative 3 minus 30 is negative 33. And so this is the simplified or as far as we can go with this original expression. And so this is our answer, 7x y raised to the power 4 minus 8x squared minus 33. And you could just simply follow the color coding, see what's going on here. I think it makes it a lot easier when you're trying to study to just open up the slides and look at what's going on with the groupings. Because essentially all you're doing is, again, you're a matchmaker, okay? And you're just matching all the terms that are similar until you have no similar terms in your final expression, okay? When you're adding polynomials with more than one variable, know that it requires the same process as adding polynomials that have only one variable. Okay, so all you need to do is just remove the brackets and then combine the like terms across both polynomials. And then remember, again, that only like terms can be combined, okay? So in this example, we're told to add 3x squared plus 6x plus 3y plus 3xy, excuse me, to 5x squared minus 6xy plus 14y. Okay, so when we look at our operation, it's positive, so there's no need to distribute across. We just simply drop the parentheses, and then we go ahead and start grouping our like terms. So our first set of like terms are 3x squared, which we get from here, and 5x squared, which comes from here. 3 plus 5 is 8, and so we have 8x squared. Then we move on to our next set of like terms, and we see that 6x is the only term like it that appears in this entire expression. We don't see any other term here that just has x, right? So we write down 6x. Then we move on to our next set of like terms. We have 3xy, and we have a negative 6xy. And so we know that 3 minus 6 is minus 3 or negative 3. And so positive 3xy minus 6xy leaves us with a negative 3xy. Okay, and again, as you notice, we're just simply treating this as a regular addition or a subtraction. And then once we've found our coefficient, we just simply tag on the relevant variables. So in this case, we add 3 to negative 6. The answer is negative 3. And then we just tag on the variables associated with the terms that we are working with. And then we check our expression again. The only thing left over is 14y. And there's no other term in our original polynomial that just has y, or that just has a coefficient in the variable y. And so we just write down 14y and we're done, right? So this is the final answer to this particular expression right here. All right. So when you're subtracting polynomials that contain more than one variable, just know that it's exactly the same as subtracting polynomials that contain only a single variable. Again, you want to remember to distribute the negative sign across the second polynomial when you remove the parentheses. And then also remember that only one like term, that only like terms can be combined, okay? And I sound like a broken record repeating, but I think it's worth the repetition so that you have it in your mind and that you're not writing down the wrong expression as your answer, right? Because you've combined terms that shouldn't be combined, okay? So in this example, we're told to subtract 3xy squared plus x plus 2xy plus 4 from 7xy squared plus 2xy minus 16. So again, we start by distributing the negative sign across everything to the right of the negative sign. So negative 1 times 7xy squared gives us a negative 7xy squared. Negative 1 times 2xy gives us a negative 2xy. Negative 1 times negative 16 gives us a positive 16. And so we drop the parentheses write down our new set of terms, and then we proceed with what? Grouping the like terms, right? 3xy squared minus 7xy squared is negative 4xy squared. And then we move on and find our next set of like terms. We see that, okay, only x exists on its own. So we write down x. Then we move on to our next set. We have 2xy and we have negative 2xy. So we have a positive 2xy and a negative 2xy. We know that 2 minus 2 is 0. So 2xy minus 2xy is 0. These two terms cancel out. That's why I kind of very lightly drew a line through there. And so there's nothing going down there for 2xy because they've canceled each other out. Then we move on to our next set of like terms. We have our coefficients, 4 plus 16, which is 20. And so this is our final answer, negative 4xy squared plus x plus 20. And notice, like I said earlier, there's no xy term in this final simplified answer, simply because 2xy minus xy is 0, okay? So more practice questions. Make sure that you're working on these, okay? Okay, so on to lesson 11, which is on multiplying polynomials. And the key ideas to pay attention to here is that there are a number of ways to multiply polynomials. The basic concepts in all of these different ways or these different approaches involve learning procedures for multiplying constants, variables, and exponents, okay? So a common method for multiplying two binomials is called FOIL for short, a pictorial representation of the FOIL method, so that it can be easier for you to conceptualize. I got this from calcworkshop.com. Let's say that you're asked to multiply A plus B times C plus D, okay? So applying the FOIL method, FOIL, by the way, F in FOIL stands for first, the O stands for outer, the I stands for inner, and then L stands for last, right? You simply start with your first terms within both brackets, right? So our first term is A in the first bracket. In our second bracket, the first term is C. So we multiply those two together. A times C will give you AC, okay? Then we go to our outer portion. We multiply the first term by the outer term. A times D will give you AD, okay? Then we go to our inner terms. So the terms that are closest together, if you will. Well, let me not say that because they're all relatively close if you want to approach it that way. But the terms that are inside the entire expression, if you will, right? So that would be B times C, which gives you BC. And then B times D gives you, or you multiply B by the last term or whatever is left over, and that gives you BD. And so this entire expression, AC plus AD plus BC plus BD, is the answer to us multiplying two binomials together, okay? And this method is known as the FOIL method, and this is the method that you should always apply when you're multiplying polynomials. And so if you notice, if I go back to one of our earlier examples, we were applying the FOIL method here when we were multiplying across, right? So we were multiplying a -1 by our first term, and then by the second and the third. So that essentially is the FOIL method. When we made sure that we multiply this -1 by absolutely everything to the right of the negative sign, right? And so that's essentially what this, well, it's coming up next. But this is telling you that there are a number of ways to multiply polynomials, and the FOIL method is one, okay? And there are different polynomials as we've seen, right? Like, so for example, okay, let me not complicate the lesson, but let's just keep going. And I think you will understand this better as we continue, okay? To multiply two monomials, I'm going to multiply each component separately, as we just saw in the FOIL example. Start by multiplying the coefficients or numbers, and then if there's no coefficient given, simply assume that the coefficient is 1, as I mentioned earlier in the lesson, right? So in this example, we have xy. There's no coefficient in front of x, and so we assume that the coefficient is 1, so xy is equal to 1xy, okay? If this was a negative xy, we would assume that the coefficient is -1, and we would have a -1 xy on the right-hand side of the equal sign. Then you multiply each variable separately by adding the exponents of the like variables. Remember that a variable with no exponent is a variable that's raised to the power of 1 or to the first power. So for example, and as mentioned earlier, x is equal to x raised to the power of 1, okay? So here, when we're being asked to multiply x by x cubed, you would simply just add the powers. So 1 plus 3 is 4, so x times x cubed is x raised to the power of 4, okay? All right, so in this example, we're being told to multiply 2ab by 4b. We can start with our coefficients as we were instructed, right? So 2 times 4 is 8, okay? Then, oh, by the way, before I go on, you want to work from left to right, as always, right? So our leftmost term here is 2. 2 times 4 is 8. Then we move on to the next term, which is a, and we see that there's no a in the second term here, so you just write down a. Then you go back to your first set of parentheses, or the first term in parentheses, and we see that what we have left over is b. B times b is b squared, right? As we saw earlier, there's no exponent on b, so we assume that both variables here are raised to the power of 1. So b times b is b squared, or simply 1 plus 1 is 2, right? So you would raise b to the power of 2. And so combining everything that we found, 2 times 4, 8, times a times b squared is our answer to multiplying 2ab by 4b, okay? When you multiply a monomial by a binomial, make sure that you multiply the monomial by the first term in the binomial, then multiply the monomial by the second term in the binomial, and then finally add the resulting terms. And that'll make sense in the next example. So here is our example of multiplying a monomial, in this case, a one-term polynomial, so 2z squared, or I should say negative 2z squared. And here's our binomial z plus 3yz. So again, you want to start by distributing the negative sign. Negative 2z squared times z gives you negative 2z cubed. You can follow this approach. I think it's more complicated and you're more likely to make mistakes this way, but let's just go with this approach, okay? So you distribute the negative sign into the parentheses. And so inside the parentheses, we'll now have negative z minus 3yz, okay? And outside the parentheses, we'll just have a positive 2z squared, okay? Then you want to multiply the monomial by each term in the binomial. So again, this is our monomial. Our new monomial is 2z squared, and we're going to multiply it by every single term inside the brackets, okay? So 2z squared times a negative z gives you a negative 2z cubed. And again, if you look at your exponents, we have z squared, and then we have z written on its own. That's the same as adding the two exponents together, right? And so that's where this z cubed is coming from, all right? And you can see that that's what they've done here. So I tried to go in with color coding to kind of help you follow what's happening. 2 was multiplied by a -1. Again, we discussed that if you don't see a coefficient in front of a variable, you know that that means, or that implies that there's a 1 in front of that variable. So 2 times -1 is -2, which is what they're illustrating here, okay? So it's simply 2 was multiplied to -1 to give us this -2, and then z cubed was multiplied by, z squared was multiplied by z raised to the first power to give us z cubed, okay? So that's where -2z cubed is coming from, if you follow the steps right here. Then onto the final term in our expression, 2z squared multiplied by -3yz. So again, you just start from outside in. 2 times -3 is -6, okay? Z squared times z will give you z cubed, as we just saw. And then y is the only variable like it. And so you just write down y. And so for 2z squared times -3yz, we have a -6yz cubed. But again, this is kind of a tedious way of going about it. What I just do is look at the original expression. We have a -2z squared. So we know that everything here needs to be multiplied by the first term. And in our first term, we see that we only have z, right? So z raised to the power of 1, we have z squared. We know that we're going to add 2 plus 1. And so we have a negative z cubed, okay? So to get our first term here, -2z squared times z gives us a -2z cubed. And then go back to your expression again. We know that everything here needs to be multiplied by everything here. So we start with the coefficients. -2 times 3 is -6. We write down -6. Z squared times z is z cubed, right? Because we're simply just adding the two powers. And then what do we have left? Y. You just write down y, okay? It's up to you, whatever method you feel like applying. So like this note tells us, where is it? I think it's in the first. Yeah, there are a number of ways to multiply polynomials, okay? So I just showed you two different ways. I showed you the book's approach, right? First, you start by distributing the signs, then you drop the parentheses, and then you multiply each monomial term by the terms in the binomials, and then you add, or you can just simply go directly, like I showed you. Whichever one makes you feel more comfortable, okay? But just know that there's more than one way of approaching it. It's just a lot easier to know that you're simply, again, like I said earlier, think of it as matching, right? So for example, look at your monomial term or your single term outside the brackets, and then you want to match, right? So -2 is our coefficient. We look at our first term. We know automatically that when there's no coefficient or when there's no number written next to a variable, we assume that there's a 1 there, right? So -2 times 1 is -2. You write down your -2. Then we're done with our coefficients, right? So we go to the first variable in our term, and that's z squared, right? And then we go back to our first term. We see that we have z, and so we're just going to add the powers. 2 plus 1 is 3. We write down z cubed, and now you're done with the first term, right? So you can even cross out z if you like, if it helps you focus, or you can cross out the terms as you're going. So we go to our second term, right? We've crossed out z. -2 times 3 is -6. You write down 6, you cross out the 3 to remind yourself that you're done with it, right? Then you go to your next, and remember, when you're multiplying, right, you're grouping terms together. So you've already multiplied this -2 by 3. So you don't have to worry about the 2 anymore, or the -2. And you don't have to worry about the 3 anymore, okay? So what's left over? We have z squared. Well, we'll multiply, we have to find another variable within this term that's z, right? And we have one, it's z raised to the power of 1. So we know that z squared times z is z cubed. And so now we're done with both. Well, what do we have? We still have a variable left on this side, right? And that variable is y, so you just write that down, okay? And now you know that you've distributed this monomial evenly across terms, or by evenly, you've made sure that you've multiplied this monomial by every term in the binomial expression, okay? And so now you're done with this particular procedure, okay? And when you look at your final expression, again, we know that we cannot combine these two terms together. Why? Because in our first term, we have a coefficient and then a variable cubed, and that variable happens to be z. In our second term, we have a coefficient and we have two variables, one raised to the first power and one raised to the third power. Okay, so these two terms are not the same. So we can't do anything more with this, right? So this is our final answer, all right? I want to mention that when you're multiplying, so what I just said in terms of combining like terms, that only applies to addition and subtraction, right? So in this particular instance, we were able to multiply -2z squared
by
and we're able to multiply -2z squared
by
3yz, because that particular rule doesn't apply to multiplication, okay? So keep that in mind when you are multiplying. You can multiply the terms that are not the same. But when it comes to your final answer, you got to make sure that you're not adding unlike terms, okay? Here's a test of where you always finish the FOIL method by combining like terms after you've multiplied, okay? And that's exactly what we just did here. We multiplied terms, okay? And then we combined like terms, and then we ended up with our final expression that has unlike terms. So a good way to check your answer, your final expression, is to make sure that there are no terms that are similar left over in your final expression, or make sure that each term in your expression is different. So when I say expression, an expression is a group of terms, and a term, as we explained earlier, is a coefficient with a variable raised to a certain power, or just a coefficient written on its own within a polynomial groupings or a polynomial expression. So an expression, again, is a bunch of terms grouped together. So you can think of a term as your, and then the
word
expression as your sentence, if you will. So yeah, always make sure that you combine like terms once you've done your multiplication, okay? In this portion of the lesson, we're going to look at multiplying two binomials. You want to multiply the first terms, then the outer term, then the inner term, and finally the last term, as I showed you earlier using the FOIL method. You want to add the results and combine like terms, and you can remember this process by using the acronym FOIL, which stands for first, outer, inner, last, okay? I introduced it earlier in the lesson because I thought it would make it easier to understand what was happening in the examples that we saw. You already have a good understanding of what this means, right? So in this example, we're being asked to multiply 2g squared plus 9 by 3g squared minus 4. So we're going to use the FOIL method, right? Let me zoom in so that you can see a little bit easier. So we're going to start with the first term, and we're going to multiply the first term in our first set of parentheses by the first term in our second set of parentheses. So 2g squared times 3g squared is what you see going on here. 2 times 3 is 6. G squared times g squared is g raised to the 4th power. Okay. Well, let me just go across so that we don't have too many steps going on at once. All right. So first you want to group your first set of terms. All right. So we've done that here. 2g squared times 3g squared. Then you multiply by the outer, right? The O in FOIL, right? So we've done our first. Now we're on the outer. So 2g squared times a -4. Okay, and so that's what you see going on here. And you always want to make sure that you're paying attention to the signs, okay? Know that when you're multiplying, no matter what happens, you're always going to be adding. And the reason is because multiplication is really additive, right? So 2 times 3 is a good example. 2 times 3 is 6. We know that that 3 is telling us that we're adding 2 3 times. 2 plus 2 is 4. 4 plus 2 is 6. So that's why 2 times 3 is 6, right? So you can think of multiplication and addition as cousins. I think I mentioned this in one of our very early lectures in October. When you're multiplying polynomials, the same applies. You know that whatever you find as your product of multiplication, you'll be adding whatever you find together. The easiest way to make sure that you're not forgetting the signs, because the negative signs become important. When you're grouping, make sure that you're including whatever sign is associated with the term in question, right? So for example, we multiply 2g squared by 3g squared. We don't write down the positive sign, but we know just by convention that when there's no sign written in front of the number, you assume that it's positive, just like in real life, right? Like if you see, let's say you're an accountant and your client bank account is showing 3, right? You know that that means that they have $3. But if your client's bank account is showing -3, you know that they're overdrawn by $3. But when it's showing 3, you don't see a positive sign, right? But by convention, you know that that means that they have +3 or $3, okay? So the same applies here, right? So you're not only multiplying the terms, you're also paying attention to the signs next to each term, okay? So we're done with our first. We go to the outer. 2g squared times -4 is where this expression is coming from. And again, because we know that multiplying is additive, we're just going to be adding whatever we find as our products, right? So then we move to the inner, right? And we multiply 9 by 3g squared, and that's what we see here. Okay, then we multiply 9 by -4, and that's what we see right here. Okay, and again, we're making sure that we're including that negative sign, because if you just multiply 9 by 4, you would get +36. That's not the right answer. Okay, so you want to make sure that as you're doing your FOIL multiplication, that you're paying attention to the signs and that you're grouping the signs with the relevant terms. Okay. So once you've done your FOIL multiplication, simply simplify each product. And you simplify each product by multiplying, right? So you go back to your now simplified expression and you multiply. So 2g squared times 3g squared is going to give us 6g raised to the power 4. Why? Because 2 times 3 is 6, and g squared times g squared is essentially us adding the powers. 2 plus 2 is 4. So we know that 2g squared times 3g squared is 6g raised to the power of 4. Plus 2g squared times negative 4. Well, we know that 2 times negative 4 is negative 8. So we drop our positive sign and we just write down minus 8g squared. And then obviously we're writing down g squared because the second term doesn't have a variable raised to a power that's similar to g, right? And so we're just going to write down g squared as it appears, right, in this particular combination or this particular product. Then we move on to our next term. We know that 9 times 3 is 27. And again, g squared is a loner here, so you're just going to write down g squared next to 27. Then you move on to your final term in your expression. 9 times 4 is 36, but it's a negative 4, right? So we know that when you multiply a positive number by a negative number, the negative number dominates, okay? So 9 times 4 gives you negative 36. And so now we have our simplified, or we've simplified our product even further, or I should say expression. We simplified our expression even further, right? And now we continue to check our expression to make sure that we haven't left any like terms over. And we can see from our expression that we have g squared or negative 8g squared, and we have a positive 27g squared, right? And so we're going to add those two terms together. Negative 8 plus 27 is 19. And so our final expression is going to be 6g raised to the power of 4. And we saw how we got that here. Plus 19g squared. And we got that by adding these two terms together. Minus 36, which we got from multiplying 9 by negative 4. Okay. And again, you can just follow the color coding to see how this is proceeding. We're just making sure that we're only adding like terms, but know that when it comes to multiplication, you can multiply unlike terms that are not similar. Okay. Practice exercises. And hopefully you're making a list of all these rules, right? Because there are so many of them. If you can think back to our earliest lesson, right? There's a lot to remember, right? So as you're working on these, on your practice exercises, make sure that you're writing down the rules so that you're not forgetting essential steps, okay?
Okay, I will.
Good, okay. So the final lesson today then is on dividing polynomials. So you can divide a polynomial by numbers, expressions, or other polynomials. The key to dividing a polynomial is to isolate a common factor that divides into the numerator and the denominator. Common factors can be numbers, they can be variables, or they can be a combination of two, such as addition, subtraction, or multiplication expressions, and we'll see examples of that. So when you're dividing by a number, make sure that the test will sometimes ask you to simplify a polynomial that is written as a fraction, okay? So to simplify, you simply want to divide the numerator by the denominator. Make sure that you're dividing using a common term, okay? A common term can be any of the following. It can be a number, it can be a variable with the number as a coefficient, okay? And it can be a more complicated expression. And again, this will make sense when in the examples that follow. You may need to factor the common term out of the numerator or the denominator before you can do the division. And we'll see what that means shortly. So in this example, we're told to simplify by dividing 3x plus 6 by 3, okay? So 3x plus 6 is our numerator, and 3 is our denominator. So the first thing you want to do is see if you can factor out anything from your polynomial. And we know that 3 is a multiple of 6. So we can factor out 3 from our polynomial, which is what they've done here. So another way of writing 3x plus 6 is 3 times x plus 2. And we remember our FOIL method, we know that 3 times x is 3x, and 3 times 2 is 6, okay? So this is just another way of writing this numerator here, and this is what this statement is telling you here, that you may need to factor the common term out of the numerator or the denominator before you can do your division. So that's what we've done in this first step. Okay, then you look at your entire expression and see if there's anything that can be canceled out. We have 3 in the numerator and we have 3 in the denominator. So that can be canceled out. And then we're just left with x plus 2. We know that these are unlike terms, right? We have a variable and we have a coefficient. We can't do anything more with this. So this is our simplified version of this expression here. Let's say that x is 2. Remember, our definition of a variable is just a placeholder for a number that we don't know, right? So let's say that on the test, they tell you that x is 2. That means that anywhere in your expression where you see x, you're going to plug in 2. So for example, let's go back to okay, here, let's say that g is 2 on the test. If they tell you to multiply this expression and then plug in g to report the final answer, you would just, with your last expression, look at every instance where g appears, and you would just plug in 2. So you would have 6 times 2 raised to the power of 4 plus 19 times 2 raised to the power of 2 minus 36. You put that in your calculator, and whatever you find is your final answer, okay? So here, the reason that this is a simplified version of this is because whatever you plug in here, get the same answer with this final version. For example, if we plug in 2 here, okay, 3 times 2 is 6. 6 plus 6 is 12. 12 divided by 3 is 4. Now we know that x is 2. So if we plug in 2 here, 2 plus 2 is 4. So we've just found the same answer with 2 different expressions. And so that's essentially what this simplification is doing, is that by simplifying, you're basically writing this term, or you're writing this expression in a different form, or using a different form, but they both mean the same thing. And that's what I was trying to illustrate. If we decided to plug in 2, for example, we would get the same answer. If x was 1, okay, 3 times 1 is 3. Plus 6 is 9. 9 divided by 3 is 3. If you plug in 1 here, 1 plus 2 is 3. And so this will be true for any number you plug in here, okay? Let's say you plug in 10. 3 times 10 is 30. 30 plus 6 is 36. 36 divided by 3 is 12. So if you plug in 10 here, 10 plus 2 is 12. So I'm trying to illustrate to you what's going on when you're seeing a variable and also when you're simplifying an expression. When you're seeing a variable, it's just telling you that no matter what number you plug into that mathematical expression, the outcome will always give you the same answer as the simplified expression. Okay, so when you're simplifying a polynomial, they're basically telling you to find the shortest or the most condensed form of that expression that would still give you the same answer when you plug in whatever the variable is. So back to this particular example, now that we've crossed out 3 and we write down x plus 2, even though it looks kind of weird, x plus 2 is indeed the simplest form of this expression. Why? Because whatever number we plug in here, we'll always get the same answer if we work out both expressions, okay? On the test, remember that you will be provided with a wipe-off board during the test, during the mathematical reasoning portion of the test, so that you'll be able to use the wipe-off board to carefully work through steps needed to solve these kinds of problems. And so I would recommend buying yourself a wipe-off board and then practicing, because you don't want to spend your test time getting used to working with it, right? Because believe it or not, like these little things tend to steal time, right? Like if you're not used to whatever surface you're working with and you're trying to get adjusted, before you know it, 5 minutes is gone. Also, as you're working on these, try to time yourself. I would suggest like maybe doing a set of 5 questions, for example, on your own, like whichever way is comfortable with a pencil, okay? And then once you understand what you're doing, try to do the same set of questions on a wipe-off board, just so that you're used to how it feels, so that you're not on the test wasting time, all right? And try to make sure that you're working as many problems as possible, okay? Dividing a polynomial by an expression is really no different from dividing by a number, okay, as we just saw. So we just saw an example of dividing by a number. You need a common term in the numerator and the denominator, and then you may have to factor out a common term, including any variables, before you can do your division. And we'll see examples shortly. So in this example, we're told to simplify 25x cubed minus 45x squared divided by 5x. Immediately when you look at this, you can see that both terms in the numerator contain x, and then the denominator also contains x. So you know immediately that you can factor out x, but you need to check how many x's can you factor out. You can factor only by the lowest occurrence. So we only have one x in the denominator. In the numerator, we have x cubed on the left-hand side of the subtraction sign, and we have x squared on the right-hand side. So that just tells you that there's at least one x in each term, right? There's one x here, there's one x here, because this simply means x times x times x, or x multiplied by itself 3 times, and there is at least one x here, because x squared simply means x times x, right? Or x multiplied by itself twice. So we know that we can factor out only one x. Then you look at your coefficients. You know that 25, 45, and 5 share a common multiple, and that happens to be 5. So right off the bat, we know that we can factor out 5x, okay, which is what's been done here. And if we draw out 5x from 25x cubed, we will have 5x squared. Why? Because when you're factoring out, you're essentially just dividing, right? So you know that 5 is a multiple of itself, of 25 and 45. So if we draw out 5 from 25, it's the same as dividing, right? So 25 divided by 5 is 5. 5 times 5 is 25. So that's where this 5 is coming from. And then if you draw out x from x cubed, when you're subtracting or when you're drawing out, it's the same as subtracting powers, right? So if we take out one x from this x cubed, we're going to be left with x squared. Or you could just simply do the subtraction, 3 minus 1, the 1 on the power of the x that you're drawing out. 3 minus 1 is 2, and so that leaves you with 5x squared. And if you apply the FOIL method, we know that 5x times 5x squared is 25x cubed, which is what we have here. So we've successfully factored out our first term. Then we go to the second term and we apply the same logic. We've already decided that 5 is a factor of 45, right? So when we draw out 5, essentially we're dividing 45 by 5. 45 divided by 5 is 9. And if we draw out an x term from here, that's the same as subtracting, right? So 2 minus 1, the 1 coming from the x term that we're drawing out, 2 minus 1 is 1. So inside our brackets, we'll have 1x, and outside our brackets, our factor is still solid, 5x, right? And if we wanted to check to make sure that we found the right factor, we can just multiply 5x by negative 9x. 5 times 9 is 45. X times x is x squared, which is what we have here, 45x squared. So now that you've rewritten your numerator in terms of the factor 5x, you look at your entire expression and you go, okay, in the numerator, I have 5x, and in the denominator, I also have 5x, so they can cancel each other out. And then you're left with this expression, 5x squared minus 9x. And now we're down to subtracting. We know that unlike terms cannot be added or subtracted. So this is our final expression, okay? If you wanted to check your answer, you could, let's say that x is 1, right? So that means that everywhere we see 1, everywhere we see x, we're going to plug in 1. So 25 times 1 cubed is 25. 45 times 1 squared is 45. 25 minus 45 is negative 20, okay? Negative 20 divided by 5 is negative 4. So if we plug in negative 1 here, if we plug in 1 here, we decided that we wanted to check our answer using, by making x 1, right? So if we plug in 1 here, 5 times 1 squared is 5. 9 times 1 is 9. 5 minus 9 is negative 4, okay? And we also found negative 4 up here when we plugged in 1. So we know that this simplest form is correct, okay? And staying true to the original expression, all right? So this is another way of checking your answer on the test. If you are, let's say you're given an expression like this, and then there's a list of, go through the motions and simplify the expression. Or you could simply, no, I think it would take longer to check each you could do that, but I think it will waste your time. So the best thing to do is know how to simplify the expression so that then you can check the options given to see if you have one that matches, okay? And if you don't have one that matches, you might want to check your steps again to see maybe you forgot to combine some like terms. So for example, if you had stopped here, right, and then you check your answers and you see this, you know that this expression contains 3 terms, where you stopped contains 4, right? So then you would just check your answer again and see, oh, you have 2 like terms here that can be combined. And once you do that, then you'll have an answer that's matching. What point was I trying to make here? Oh yeah, checking your answers.
Checking the answer.
Yeah, when you're checking your answers, I think there are 2 ways to check your answers, right? You can either plug in a number into the expression and then plug in the same number into the answers and see which one gives you the same value, right? So let's say you get 10 in your question and then you plug in 1 or whatever number you choose into your answer choices. Whichever one gives you 10 is the simplified form. But that could take a lot of time because you would be plugging in 1 into 4 different, 5 total, right? Your initial expression and then the 4 answer choices. It would be a lot easier to just simplify the expression right away and then match whatever outcome you have with your multiple choices, right? To see which expression is the simplest. But if you have time to spare and you don't feel like simplifying the expression, plugging in a number is another way to find out which of the answers is correct, okay? But definitely learn how to simplify because it's something that you will be asked to do on the test. When the numerator has two added or subtracted expressions that both include the common term, it may be easiest to split the polynomial into separate fractions and then simplify them separately. Doing this will help you to keep straight exactly which terms to cancel out, and we'll see that in the next example. So here, we're being told to simplify x times x plus 7 minus 3 times x plus 7, that's our numerator, and that's being divided by x plus 7. So immediately, we can see this entire expression that there is a term that repeats itself, right? X plus 7, x plus 7, x plus 7, right? And so what this is telling you here is that in the example that we're seeing, the best thing to do is to separate the polynomial into two fractions and then simplify them separately, okay? So this first term will be the numerator for our first fraction, x times x plus 7, and our denominator stays the same so we're going to have x times x plus 7 divided by x plus 7 minus, and that's because we have a subtraction here. If we had addition here you would have addition, but here we have subtraction, so here we're also going to have subtraction, minus 3 times x plus 7 divided by x plus 7. So essentially, these two expressions are exactly the same, right? We just broken them, or we separated them so that we can simplify, right? So now again, you look at your separated fractions and you see that x plus 7 is still a shared term across both of your two fractions. And so you would just simply cross out x plus 7 in the numerator from x plus 7 in the denominator, do the same thing on both sides, okay? And then what you're left with is x and 3 here. And so your simplified expression is x minus 3. And in my version of the book, I have the Kindle. It didn't have the final answer. That's why I have it written here. I don't know how it is in the version of the book you have, but just pay attention to this. Once you've canceled out your like terms, know that you still have x in the numerator here. You have 3 in the numerator on this side. And so that just simplifies to x minus 3. If you went through the motions and you plugged in a number here, whatever you found for this expression should be exactly the same here until you know that you have the right answer, okay? The final concept that we're going to look at today is undefined expressions. So when the denominator of an expression equals 0, the expression is undefined. It's known as undefined. So in this example, we're told to find the value, let me zoom in, of x squared plus 2xy plus y squared divided by y minus x when x equals y. So essentially, here we're being told that everywhere you see x, you're going to replace it with y. Earlier, I gave you examples of, say, if you were told that x equals 1, anywhere you see x, you would replace it with 1. In this example, we're told that anywhere you see x, replace it with y. That's what x equals y means. So we would have to go back into this expression. Here we have x squared, we would replace it with y, so we would have y squared. Here we have 2xy, we would replace x with y, so we would have 2yy or 2y squared, because y times y is y squared. And then this stays the same. And here in our denominator, we would also replace x with y. But what happens when you subtract y from y? Y minus y is 0. Why? Because we have in front of y, or as we saw earlier, when you have a variable that doesn't have a coefficient or a number next to it, you assume it's 1, right? Or 1y minus 1y, they're like terms. So you're essentially subtracting two things that are the same from each other. 1y minus 1y is 0. Dividing by 0 leaves you with an undefined expression. there's a mathematical theoretical explanation as to why dividing by 0 is undefined, but just know that there's no solution to that expression, and that's why it's known as undefined. In this particular instance, because we're dividing by 0, there's no solution, so this is known as an undefined expression. So the book is wanting you to pay attention to that in case you get an example where they give you an expression and then they say x equals y like they've done here, and then they give you a set of simplified solutions, and then maybe choice C is undefined. Undefined is also a solution. Well, I shouldn't say a solution because an undefined expression has no solution. But in that example, or in that instance, undefined would be the answer, right? Because you can't divide an expression by 0. So just pay attention to that because it could be a scenario on the test. More practice questions for you. And like I said earlier, I've also posted the quiz assignment as well. I posted that earlier this afternoon. I keep putting these practice exercises after each lesson to just kind of make you aware that you need to be working on these problems as much as possible, even if it's just like 5 a day, you know, and then some days you do 20 and other days you do 10, but make sure that you're doing something every single day. Make sure that you're working on these. Yeah. All right, so that's it for today.